Team, what we want to do is get down to a reduced row matrix. So we're going to do a series of operations, this guy, to get it down to that spot where it's a reduced row. And so our first approach is to go ahead and kind of trying to look ahead. And like, to me, this is like one of the hardest parts. This is see like what we do and why we do it in what order. So our first one is to swap R1 and R2. So R1 becomes R2. And so when we do that, we end up getting, and I'm going to switch around a little bit. I do 2x plus 1y plus, and for me, I just like to put the 0 there because it helps the placeholding. And then I'm going to bring down 5x plus 2y plus 1z is equal to 0. And so at this point, I'm positioning myself to try to be able to eliminate, have that insights of what to eliminate, which comes with practice. All right, next step is that we're going to take half of row 1. So we're going to take half of row 1, and that will become our new row 1. So we're going to take this guy right here, we're going to take him by 1/2. And so this becomes x plus 1/2 y plus 0z is equal to 0. And we bring down the rest. 5x plus 2y plus 1z is 0. Now, I chose to use x, y, and z just because I'm more comfortable with those in the 3 dimensions versus using like getting confused with the different like x1, x of 1, x of 2, x of 3. So then when I get done, I'll just switch it back over to x1, x of 2, and y x of 3. Excuse me. All right. So what you're seeing here, hopefully, is that we're getting to the spot where it's like now we have like the 1. We're trying to reduce row echelon on this guy to get it down to where it's like we're eliminating things off of here. So now if I come along on the next one, change colors again, and we're going to take R2 plus -5 times R1, and that's going to give us our new R2. So we bring down our R1, so x plus 1/2 y plus 0z is equal to 0, right? So we got that guy, we bring him down, all right? And now we're going to take -5 times this guy and add it to this, and that'll give us our new R2. So -5x plus 5x, those x's are gone, so that gives me 0x, plus a -5 times positive 1/2 is -2.5, plus 2 would be, and let's get rid of that plus sign. Let's put a minus sign right there instead, just for good housekeeping, minus 1/2 y. -5 times nothing is nothing. Plus 1 is plus 1z, and that equals 0. So now we've done that idea of getting rid of, and so now we need to try to eliminate like another row along the way, or not a row, but another column or in there. And so we're going to take on this one, and we're going to take -2 times row 2, and that will give us our new row 2. So I like to kind of write it here. This is like my way of keeping track of it. So the first row stays the same. And then I simplify the next. So -2 times nothing, that still gives me nothing x. You might leave that blank. Like I said, I'm just doing that because it helps me visually. I have -2 times 1/2, -1/2, so it's going to be plus 1y. And then -2 times that is going to be minus 2z is equal to 0. All right, and so at this point, I'm down to like a reduced row echelon. I've gotten rid of the first term here. I've got myself down to where I only have 2 variables left. And this allows me to be able to take this guy right here and say, okay, so I know that 1/2 y is equal to -z, or we can flip that around. Let's just flip that around. Let's do this. So z is equal to -1/2 y. And I know that y, I'm so sorry. I did the same thing I did on my last video. Let me back up, press clear, and let's get rid of that. I said that wrong. I just don't want to back up all the way. So sorry about that. So there's no z here. That's one disadvantage of writing that in there. You might get confused or might trip yourself up. I have x is equal to -1/2 y. And on this one, I come across and I get y is equal to 2z. All right, so now we're in this idea of this like we know we only have one solution to this situation, but we have this, we reduce it down as far as we go. We can't go any further. And this is our first foray into linear algebra. So what that allows us to do is it allows us to come up with a constant. And this constant is referred to as a free variable. And what that free variable basically allows us to do is it basically can take on the value of any real number, right? And so t becomes this parameter that I can use to represent any real number that we know. So I could do this where t is equal to 1 or t is equal to 2 or whatever to be able to kind of find representations. So in this case here, since we've gotten our spot, we can kind of make a decision on which variable we want to let be t. So we'll just let z be equal to t. So what that does for us is it's saying that, like, if z is equal to 1, right? So if z is equal to 1, then we come up here, and this becomes y is equal to 2t. So if z was equal to 1, then y would be equal to 2. Okay, it comes up here. So we know that x is equal to negative 1/2 y, but now y is equal to, so we got negative 1/2, but y is equal to 2t. So we simplify that and we get negative t. So if t is equal to 1, then z is equal to 1, which means y is equal to 2, which means x is equal to negative 1. And that allows us to kind of look at any scenario possible that we might come across inside of our linear algebra system. So that's what we call this. It's a parameter. It's like basically working in like a parametric type situation where we're trying to eliminate and find. So how do we know we got there? Well, because we got to this spot where we had done everything we could do. You know, like we were at this spot where we could go ahead and, I just drew a box on the wrong spot. That's why you don't write 0, because the 0 will confuse you like I just did right there. Sorry about that. I just erased a little bit. But so now we got to this spot where we're like, okay, we have this equals 0 and we have this equals 0. So we've gotten this thing down kind of as far as we can go. And so we can then come over here to this side and make these statements, which then we can then say, okay, this is definitely going to be a free variable situation, a parametric situation.